So here's our position. We've got to get all the way to taking S double prime, and in taking S double prime, we need to set it equal to 0 to find out when the it's equal to 0. So let's think about taking that first. So let's take the first derivative of S. I think I'm going to get S prime is equal to negative 10 pi sine of pi t. Tan is a constant. The derivative of cosine is negative sine. Don't forget the chain rule. And then I'm going to take the derivative of that so I can find out what S double prime is. And it's going to be negative 10 pi squared cosine of pi t. So let's find out when that S double prime function is equal to 0. When is negative 10 pi squared cosine pi t equal to 0? Well, it's going to be where cosine is equal to 0. Let's say normally cosine starts up here and goes down, goes up and goes down. So normally it's equal to 0 at pi over 2. So it looks to me like at t equal 1/2, at t equal 1/2 pi times t, sorry, at t equal 1/2, you plug that in there, you get pi over 2, and that's one of the places where cosine is equal to 0. Here is 3 pi over 2. So at 3 over 2, it's going to equal to 0. And how many times? For 4 seconds. And then the next time we're at 0 is at 5 pi over 2. 5 pi over 2. The 5 over 2 is bigger than 4 seconds. So here are the 2 times when it reaches its maximum speed. The second question it asks is, where is
Wait, is that the maximum speed or the location of maximum speed?
No, this is the when. At t equal 1/2 and at 3/4, the cart is at maximum speed. The next question is, where is it when it does that? And S of 1/2, position at the position at 1/2. Oh, back to cosine, it's equal to, so it's going to be 0 at time 3, at time 1/2. It looks like it's going to be at 0 at time 3/2 as well. So where is it? It's at 0. So what I guess you imagine is that the cart moves, it reaches its maximum speed at 0, and then as it continues on there, it's starting to slow. And of course, then it starts to go back the other way, and when it goes back the other way, it reaches its maximum speed at 0, and then starts to slow down again, because it's gonna ping pong between that negative 100 between -10 and 10, back and forth. And as it goes past 0, it has to start slowing down so it can come to rest at -10 before it heads back again. The next question is, what is the magnitude of the acceleration then? Well, I think we've already found that. The magnitude of the acceleration has got to be equal to 0. Well, because in order to find where speed is maximized, we went to the acceleration and we found out where it was equal to 0. We purposely said velocity / speed is maximized when acceleration is 0. Part B, where is the cart when the magnitude of the acceleration is greatest? What is the cart's speed then? Okay, well, how can we maximize acceleration? It seems to me that when we want to maximize velocity, we took the next derivative and we set it equal to 0. If I want to maximize acceleration, I'm going to take the acceleration and take its derivative, finding the jerk, and it's going to end up being 10 pi sine of t. Hello. Doing some problems from 4-4.
Just 10 pi would be 10 pi.
Oh, 10 pi, sorry, 10 pi cubed. There's a pi in there too. Sorry. So when is s triple prime going to equal to 0? So we can find out where the maximum acceleration is. Well, it's going to be where sine is equal to 0. Sine starts at 0, comes down, comes back up. So at 0, at 1, and at 3.
At 3 or at 2?
Wait, hold on. This is essentially really 4, right? Oh, hold on. 4, 3. I'm sorry. We were incomplete here. We left off 5 pi. I, for some reason, thought 5 pi is less than 4. It's not. And also 7 pi. Or 7 pi. 5 over 2 and 7 over 2. So this is going to be 0, 1, 2. All of the integer values of t is where sine is equal to 0, and that's where the jerk is going to equal 0. And it seems to me when they're asking when's the acceleration maximum, that means the derivative of acceleration has to go from positive to negative. So we might even say that the acceleration is going to be largest when we go from the positive here to the negative there. That's not true over here where we go negative to positive. I guess this is probably where acceleration is being minimized. So it's actually, I would go so far as to say acceleration is maximized when s triple prime goes from positive to negative, and that happens at t equal 1 and t equal 3. Last part of B is asking, well, what's the speed when that happens? Well, finding out the speed is finding out the value, the absolute value of the velocity. So the absolute value of negative 10 pi sine of pi, well, wait, sine of pi is 0, and that's at 1, and this speed at 3, you're going to find out is 0 as well. So the maximum acceleration is happening when the card is at rest at these two endpoints. So that's a lot of stuff.
Are there any like quiz?
Pardon?
Are there any like this complex?
Well, I mean, the idea of taking the derivative, setting it equal to 0 to find a maximum or minimum, that's definitely embedded in the quiz. Is there a cart problem with a spring? No. All right. How about we close this off and take a look at another one?